Remember from last class when we looked at all the GeoGebra apps and saw how the derivative of sine was cos x and the derivative of cos was negative sine? And remember, if you think about the cos graph and you think that the tangent is starting at 0, but then as it goes to the right, your tangents will go negative. That will help you remember that the derivative of cos is a negative sign. So now all of the rules that we've had up till now, we can now add sine to them as well, and cos. Now, first of all, everybody's okay that sine to the 4x is the same as this. Okay? But sometimes you might even want to write it like that, because you know how with the chain rule we work from the outside in? You have to be able to recognize that that 4 is on the outside. That's the first thing you're going to run into. How do we do a derivative of a power? Well, we would start by taking that 4 out in front, subtract 1 from the exponent. Okay, and again, you might want to do this, because then it really helps you see what haven't we done the derivative of, the chain rule. What's in the inside is just a sine x. Sometimes people get confused and think the sine 3x is still on the inside because of the way that it's written. So the derivative of sine is cos. And now if you wanted to write it properly, that would be our derivative. Is it good, or should I go back? That was good? Can you see any functions inside of other functions? Okay, you see there's a 3x cubed inside of a cos. So if we worked our way from the outside in, the first function we would hit coming from the outside in would be the cos. What's the derivative of cos? Negative sine. So the first thing you would do is just the negative sine part. Nothing else changes. Okay? Now what's the derivative of the inside? The function inside was the 3x cubed. Derivative of the inside would be 9x squared. Find dy dx if sine of y equals 3x squared cos x. Tell me everything you see in this question before we get started. Sorry? We've got a power rule here. Chain rule, we'd have to have something inside of a function. But this is times by each other. The x inside is just an x, so we don't have to do an actual function inside of there. But here, I'll change that dot to a red dot. Can you see that on the right side you'd have product rule? What are you going to do with the left side? If it was just y equals, it would be an easier question, wouldn't it? But it's sine y equals. Just divide by sin? I think that's not allowed. Right? Okay. Can you get y by all by itself? Well, there is a way. You'd have to do sine inverse of both sides. But then we'd have to know how to do the derivative of sine inverse, and we haven't learned that yet. So then the other option, remember this? Whoa, do I remember how to spell it? There we go. Differentiation. Do you remember implicit differentiation? Where you do the derivative with respect to y of everything, and in this case, on the left side, there would be a chain rule. So we need to find the derivative of the whole thing doing one thing at a time. So let's start with the left side. If we do the derivative of sine y, working on our outside, the first function is sine. What's the derivative of sine? Cos. So you'd have cos y. Then the function inside, what's the derivative of y? Y prime or dy dx equals. On the right side, there's where we have our product rule. Keep one of them the same. Do the derivative of the other one. Plus keep the other one the same. Derivative of cos is negative sine. And now finally, if I wanted to get dy dx all by itself, all I'd have to do is divide by cos of y. And we get the derivative.